You know what's crazy? In 1968, a race car passed NASCAR's technical inspection, won the pole position at Daytona, and then officials discovered it wasn't even the same size as a real car. Or was it? Look, racing has always been about pushing boundaries, but some teams pushed so far, they literally rewrote the rulebook. I'm talking about fuel tanks that weren't fuel tanks, weight that vanished into thin air, and enough horsepower hidden in plain sight to make officials question their own sanity. Here's the thing. These weren't just cheaters trying to get ahead. These were engineers who looked at a rulebook and saw what wasn't written there, and they exploited those gaps with such brilliance that 50 years later, we're still talking about their tricks. This is legacy motoring, and I spend way too much time thinking about the brilliant engineering loopholes that change motorsports forever. If you're someone who appreciates the technical genius behind racing's most legendary rule benders, make sure to hit the subscribe button and give this video a thumbs up if this helps you out. Today we're diving deep into 5 racing tricks so ingenious, so perfectly executed, that sanctioning bodies had no choice but to ban them permanently. We're talking acid-dipped bodies that you could dent with your finger, Buckshot that mysteriously appeared and disappeared, nitrous systems hidden where nobody thought to look, fuel lines that held more fuel than the actual tank, and a Chevrolet that may or may not have been built to the wrong scale. These stories aren't just about breaking rules. They're about the razor-thin line between innovation and cheating, and how that line has defined motorsports for generations. Let me start with something that sounds absolutely insane, but happened more times than you'd think. Picture this. It's the late 1970s, Bristol Motor Speedway, a night race under the lights. The cars are screaming around the half-mile bullring, and on pit road, something very strange is happening. A crew member is frantically sweeping up what looks like gravel, except it's not gravel. It's lead buckshot, pouring out of a race car like a slot machine hitting jackpot. That scene, that moment of panic, that's where our first story begins. Trick number 5, the vanishing weight. Darrell Waltrip's Buckshot Bertha? Now, you might be thinking, how does weight just vanish from a race car? Well, here's what most people don't realize. NASCAR in the 1970s had a pretty straightforward rule about weight. Every car had to meet a minimum weight requirement before the race started. Officials would roll your car onto the scales during pre-race technical inspection, and if you hit that minimum, 3,700 pounds, give or take depending on the year and series, you were good to go. The thing is, NASCAR only weighed cars before the race. Not during, not after, just before. And if you were smart enough, creative enough, and just a little bit devious, that loophole was big enough to drive a Monte Carlo through. Enter Gary Nelson, crew chief for DeGard Racing and one of the most brilliant mechanical minds ever to wrench on a stock car. Nelson looked at that rule and saw opportunity written all over it. See, the rule book said your car had to weigh a certain amount at inspection, but it didn't say anything about what happened to that weight once the green flag dropped. So in 1976, Nelson walked into a gun shop and bought bags and bags of lead buckshot. You know, the little pellets you load into a shotgun shell. Then he went back to the shop and got creative. The team's 1974 Chevrolet Monte Carlo, affectionately nicknamed Big Bertha by the crew, had a stock Chevrolet frame with hollow frame rails. Those frame rails run the length of the car, providing structural support, and they're essentially metal tubes, empty metal tubes. Nelson saw those hollow rails and had an idea that would work for years before anyone caught on. He removed the battery from its normal position behind the left front wheel, jacked the car's front end up as high as it would go, and then took a funnel and poured 75 to 100 pounds of buckshot straight into the left side frame rail. Just poured it in like you're filling a gas tank. The buckshot would settle to the bottom of the rail, distributed along the length of the frame, completely invisible from the outside. The car would roll onto the scales and pass inspection easily, meeting the minimum weight requirement. But here's where Nelson's genius really shows. He designed a special release system right where the jack post sat. The jack post is the reinforced tube that crews use to lift the car during pit stops. Nelson installed a cap on that tube, a plug that driver Darrell Waltrip could loosen from inside the cockpit with just half a turn. It was positioned so that once Waltrip reached down and twisted it, the cap would fall out, and all that buckshot sitting in the hollow frame rail would slowly start rolling out through the now open jack post. Here's what most people don't realize about how this actually worked during a race. The buckshot didn't just dump out in one big pile. It took time, usually a couple of pace laps before the green flag, for all 75 to 100 pounds to drain completely. The pellets were small, dark gray, basically the same color as asphalt, and these scattered across the track surface where they were nearly invisible. Even if someone noticed them, they'd probably think it was just debris or gravel that had worked its way onto the racing surface. Nobody would think, oh, that must be lead buckshot draining from a race car's frame rail. It was the perfect crime, hidden in plain sight. The performance advantage was massive. Losing 75 to 100 pounds during a race gave Waltrip a significant edge in handling, acceleration, braking, and tire wear. On short tracks like Bristol, Martinsville, or Richmond, where races are won and lost by hundredths of a second per lap, this advantage was worth multiple car lengths over the course of a race distance. Think about it this way. If you're carrying an extra 100 pounds and your competitor isn't, you're working harder in every corner, braking earlier, accelerating slower, wearing your tires faster. Over a 500-lap race, that compounds into an enormous disadvantage. By dumping that weight, Waltrip was essentially driving a different, faster, better-handling race car than everyone else. The system was virtually undetectable. The car passed technical inspection legitimately because at the moment of inspection, it was legal. Once the buckshot was gone, there was no evidence it had ever been there. The frame rail looked like a normal frame rail. There was no trapdoor, no obvious modification, just a missing plug that could easily be explained as a lost cap or a minor repair. NASCAR officials had no reason to suspect anything. For years, the trick worked flawlessly. Waltrip would qualify, pass inspection, dump the weight during pace laps, and race with a lighter, faster car. Other teams probably wondered how the guard kept finding speed, but in an era when teams guarded their secrets closely, nobody was talking. Then came one fateful night race at Bristol Motor Speedway in 1978, and everything fell apart. According to Gary Nelson's own confession decades later, told on Dale Earnhardt Jr.'s podcast in an interview that had racing fans absolutely captivated, Darrell Waltrip made a critical mistake. He turned the cap, but only half a turn less than he should have. The plug didn't come loose. During the pace laps, nothing happened. No buckshot drained. The car was still carrying that extra 100 pounds. Then came the first pit stop. The crew rolled the jack into position, lifted the car, and when they dropped it back down after changing tires and adding fuel, the plug finally came loose. Right there on pit road, in full view of other teams, NASCAR officials, and anyone paying attention, lead buckshot started pouring out of the jack post like a waterfall. Nelson's crew immediately panicked and started sweeping, trying to hide the evidence. But Nelson, realizing how suspicious that looked, shouted at them to stop. "Stop! You're sweeping up a dry pit road," he told just one guy to casually sweep it up, trying to make it look like normal debris cleanup, but the damage was done. Junior Johnson's team, whose pit stall was right next door, saw the whole thing. Junior's guys knew exactly what they were looking at. Word spread through the garage like wildfire. NASCAR officials, led by Chief Inspector Dick Beatty and Technical Director Bill Gazaway, launched an immediate investigation. The trail of evidence was impossible to hide. Buckshot on pit road, a hollow frame rail, a missing plug, it all added up. NASCAR didn't even need to tear the car apart. The evidence was literally lying on the ground. In what seems almost quaint by today's standards, the penalties were relatively light. DeGard Racing was fined, Waltrip lost his finishing position for that race, and NASCAR issued a stern warning. But more importantly, NASCAR rewrote the rulebook. They implemented post-race weight checks, began inspecting frame rails more thoroughly during teardowns, and added language specifically prohibiting teams from adding or removing weight during a race. Teams could no longer simply meet the minimum weight before a race and then shed pounds once the green flag dropped. The buckshot trick forced NASCAR to close a loophole they hadn't even known existed. And here's the kicker. Gary Nelson, the guy who invented this brilliant cheat, later became NASCAR's Cup Series director. Essentially the chief law enforcement official. The guy who cheated the system ended up running it. That's not just irony, that's NASCAR recognizing that the best person to catch cheaters is someone who knows every trick in the book because he invented half of them. Nelson's tenure as NASCAR's tech boss in the 1990s and 2000s was marked by increasingly sophisticated inspection procedures, laser measurements, templates, and teardowns that would have caught his own Buckshot trick in about 5 seconds. But here's what I find fascinating about the whole Buckshot saga. Nelson and Waltrip didn't see themselves as cheaters. In their minds, they were engineers exploiting a gap in the rulebook. The rules said you had to weigh a certain amount at inspection. They did. The rules didn't say that weight had to stay on the car during the race, so it didn't. This is where it gets really interesting, because this mindset, this philosophy of if the rulebook doesn't explicitly forbid it, then it's fair game, that's been the driving force behind innovation in motorsports since the very beginning. Every major technical advancement in racing history came from someone pushing the boundaries, finding loopholes, testing the limits of what's allowed. Now let's shift gears to something that happened at the biggest race in NASCAR, the Daytona 500. Picture 1976, the sport's Super Bowl, and two drivers suddenly post qualifying speeds that make absolutely no sense. They'd been mediocre in practice all week, running mid-pack times, nothing special. Then qualifying comes and boom, they're a full second faster than they'd been running. A full second at Daytona is an eternity. That's the difference between starting on the pole and starting 20th. Something was definitely up, and NASCAR knew it. Trick number 4, the hidden power boost, nitrous oxide at the 1976 Daytona 500. Here's the thing about nitrous oxide. Your dentist calls it laughing gas, but racers call it rocket fuel. The stuff works by increasing the oxygen content in your engine's combustion chamber. More oxygen means you can burn more fuel, and more fuel burning means more power. On a big, naturally aspirated V8 like those used in 1970 stock cars, a properly set up nitrous system could add 100 to 150 horsepower in short bursts. That's not a small bump, that's like bolting on a completely different engine. Now, NASCAR's rulebook explicitly banned nitrous oxide. It was right there in black and white. No fuel additives, no performance-enhancing substances, no artificial power boosters. But here's what most people don't realize about 1970s NASCAR enforcement. It was, shall we say, relaxed. Tech inspection wasn't anywhere near as sophisticated as it is today. The inspectors were looking for obvious violations, oversized engines, illegal carburetors, things you could see and measure easily. They weren't crawling around inside chassis tubes looking for hidden pressure vessels, and that's exactly where the teams hid them. A nitrous system is remarkably simple. You need a bottle to hold the nitrous, a line to carry it to the engine, a solenoid valve to control the flow, and a switch for the driver to activate it. The bottle could be small, maybe the size of a fire extinguisher, easy to tuck behind a panel or inside a roll bar tube. The line could run through the chassis where nobody would think to look. The switch could be hidden anywhere in the cockpit. When everything was assembled, you had a system that was virtually invisible to casual inspection, but could add massive power at the push of a button. This is where it gets really interesting. By 1976, nitrous oxide wasn't even a secret in the NASCAR garage. Teams knew other teams were running it. The problem was proving it. If you couldn't find the system, you couldn't penalize anyone. And these teams were getting incredibly creative about hiding their equipment. Bottles mounted inside frame rails, lines running through roll cage tubes, switches disguised as something else entirely. It was an open secret that nobody could quite nail down. Then came qualifying for the 1976 Daytona 500, and two cars jumped to the front of the speed charts in a way that set off alarm bells throughout NASCAR headquarters. A.J. Foyt driving the number 28 Haas Ellington Chevrolet, and Darrell Waltrip in the number 88 DeGard Racing Chevy suddenly posted times that were dramatically faster than anything they'd shown in practice. These weren't small improvements. We're talking about a full second faster around a 2.5-mile super speedway. That kind of jump doesn't happen from chassis adjustments or finding the right line. That happens from finding an extra 150 horsepower somewhere. Big Bill France himself, the founder of NASCAR and a man who didn't tolerate being made a fool of, confronted Mario Rossi, Waltrip's crew chief. France didn't mince words. He told Rossi in no uncertain terms that if they didn't confess, NASCAR would cut the car into tiny sections until they found the nitrous system. They would disassemble the entire car piece by piece, and when they found what they were looking for, the penalties would be severe. Rossi, faced with the certainty of being caught, confessed immediately. He revealed exactly where the system was hidden, mounted inside a chassis tube where inspectors had never thought to look. Foyt's team had done the same thing. Dave Marcis was also caught up in the scandal, though his violation was slightly different. His car was disqualified not for nitrous, but for a movable aerodynamic device on the radiator, basically a trick shutter system that could close off airflow to reduce drag on the straightaways. 3 front-running cars, all caught cheating, all disqualified from their qualifying positions. The penalties, by modern standards, seem laughably lenient. Both nitrous teams were fined just $1,000 each and had their qualifying times disallowed. That's it. $1,000 for trying to steal the pole at the Daytona 500 with an illegal power adder. The craziest part of this whole scandal? After Foyt, Waltrip, and Marcis were disqualified, the front row of the 1976 Daytona 500 consisted of 2 independent drivers that nobody had ever heard of. Ramo Stott and Terry Ryan ended up starting first and second. It remains one of the most obscure front rows in Daytona 500 history. 2 underfunded independents who found themselves at the front of the field simply because the fast guys got caught cheating. But here's what the scandal really accomplished. It was a wake-up call for NASCAR. The governing body tightened technical inspection procedures dramatically after 1976. They started looking for hidden systems, checking chassis tubes, scrutinizing cars more carefully before allowing them on track. The penalties also got much stiffer over time. Today, if you're caught with nitrous oxide in a NASCAR vehicle, you're looking at massive fines, lengthy suspensions, loss of owner and driver points, and potentially a lifetime ban. The days of paying a $1,000 fine and moving on are long gone. The performance math on nitrous is straightforward. At Daytona, cars are running flat out for most of the lap, engines screaming at full throttle down those long straightaways. Adding 100 to 150 horsepower on an engine making around 600 is a 20 to 25% power increase. That translates directly into higher top speed, which at Daytona means several miles per hour faster through the speed traps. Over a 2.5-mile lap, that advantage compounds into a full second or more of qualifying time. The teams running nitrous weren't just a little faster, they were in a completely different performance bracket. Now, let's move on to something even more audacious. What if I told you that a team figured out how to make their race car lighter by literally dissolving the metal? Not removing panels, not using exotic materials, just taking a regular production car body and making it thinner everywhere at once. That's exactly what happened in the SCCA Trans Am series in the late 1960s, and the technique was so effective that it created one of the most dominant race cars of its era. Trick number 3, the acid bath, Mark Donohue's lightweight Camaro. The Trans Am series in the 1960s was supposed to showcase production-based race cars. The whole idea was showroom stock competition, cars that looked like what you could buy at your local Chevrolet or Ford dealership, just with racing modifications like roll cages, improved suspension, and built racing engines. The rule stated that cars had to maintain their stock body panels and original dimensions. You couldn't reskin the car in aluminum or fiberglass. You had to use the steel panels that came from the factory. But here's what the rulebook didn't address. It said you had to use stock body panels, but it didn't say anything about how thick those panels had to be. It didn't specify any process restrictions on how you prepared those panels for competition. And that loophole was all that Roger Penske and Mark Donohue needed to create something extraordinary. The technique was called acid dipping, also known as chemical milling. It's actually a legitimate aerospace manufacturing process used to reduce weight on aircraft components. The concept is simple, but requires precise execution. You take metal components and submerge them in a bath of acid, typically hydrochloric or sulfuric acid. The acid etches away material uniformly from all surfaces, thinning the metal without changing its shape or profile. How much material you remove depends entirely on how long you leave the metal in the bath. Leave it in too long and you'll eat through the panel completely. Get the timing right and you can reduce panel thickness by 30 to 40% while maintaining the panel's original shape. After Donohue crashed their first 1967 Camaro at the Briar, New Hampshire Trans Am race, the Penske team learned that other teams were having their cars acid dipped at Lockheed Aerospace in California. If their competitors were doing it, Penske wasn't about to be left behind. They immediately sent their second Camaro, notably the second Z28 ever built off the production line, to Lockheed for the acid dip treatment. The results were staggering. The process removed an astonishing 370 pounds from the car's curb weight, dropping it from 2,950 pounds down to 2,580. Let me put that in perspective. That's like removing 2 full-grown adults from the vehicle. That's like taking all the weight of a refrigerator out of the car. In racing terms, that weight reduction was worth more than any engine modification, suspension upgrade, or aerodynamic improvement they could make. But the acid bath created a serious problem. The body panels became so thin that you could push dimples into the fenders with your fingers. The metal was so fragile that leaning against the car would leave a permanent dent. The car's structural rigidity was compromised to the point that it became dangerously flexible. One observer described it as being like a 15-foot roll of aluminum foil shaped like a Camaro. The body would flex under aerodynamic load, the doors would buckle if you pushed on them, and there was genuine concern that the car might not survive a race distance without folding in on itself. Donohue, who actually had to drive this thing at racing speeds, became genuinely alarmed. This wasn't just about performance anymore, it was about survival. A car that flexes unpredictably at 140 miles per hour is a car that could kill you. The solution was elegant and groundbreaking. Donohue insisted on installing a full NASCAR-style roll cage, one of the first ever seen in sports car racing. The roll cage effectively became the car's frame, providing all the structural support that the thinned body panels could no longer supply. The acid dip body was essentially a skin draped over a rigid steel skeleton. The lightweight Camaro won 2 Trans Am races in 1967 at Las Vegas and Seattle. After the September race at Crow's Landing in Modesto, California, SCCA tech inspectors finally examined the car closely. When they discovered the paper-thin body panels you could literally bend with your bare hands, they declared the car illegal and banned it from competition forever. But Roger Penske wasn't one to give up easily. At the 1968 Sebring 12 Hours, Penske pulled off an audacious switcheroo that belongs in a heist movie. He entered 2 Camaros, a legal 1968 model and the banned lightweight disguised with 1968 grille and taillights. To get the lightweight through technical inspection, the team created identical number roundels that could be quickly swapped between the 2 cars. First, the legal car went through inspection wearing its assigned numbers. Once approved, the crew swapped the number roundels in the garage, putting the legal car's numbers onto the lightweight. Then they sent the already approved legal car through inspection again, but now wearing the lightweight's numbers. The inspector saw a car with numbers they hadn't checked yet, verified it was legal, and stamped it approved. Back in the garage, the numbers were swapped again, and the banned lightweight went out for qualifying and the race wearing its proper identification, having never actually been inspected. The subterfuge worked perfectly. The lightweight won its class and finished 3rd overall, ahead of factory Ford GT40s with far larger budgets and factory support. It remains one of the most brazen cheats in sports car racing history, not just running an illegal car, but actively deceiving inspectors through a shell game with number roundels. The SCCA's response was swift and comprehensive. They immediately banned acid dipping and implemented minimum thickness requirements for body panels. Inspectors started carrying calipers to measure panel thickness during technical inspection, something that had never occurred to anyone before. The Trans Am series instituted strict rules about material removal processes, and teams were required to prove that their body panels met minimum specifications before being allowed to compete. Mark Donohue went on to win the 1968 Trans Am Championship, scoring 10 wins in 13 races, including 8 consecutive victories. The lightweight Camaro played a role in that success even though it was technically banned for most of the season. The car's legend grew beyond its actual competitive history, becoming a symbol of how far racing teams would go to find an edge. What fascinates me about the acid dipping story is how it exposed a fundamental assumption in the rulebook. The SCCA assumed that when they required stock body panels, teams would use those panels as delivered from the factory. They never imagined someone would chemically alter the metal itself while maintaining the original shape. It was a blind spot born from limited imagination, and Penske exploited it ruthlessly. Now let's talk about someone who made exploiting blind spots into an art form. His name was Henry Smokey Yunick, and if you spent any time around racing history, you've heard stories about him. Some of those stories are true. Some are exaggerated, and some have become so legendary that separating fact from fiction is nearly impossible. But one thing is certain. Smokey Yunick looked at every rule book he ever encountered and saw not rules, but suggestions, not restrictions, but opportunities. Trick number 2. The invisible fuel tank. Smokey Yunick's 11-foot fuel line. NASCAR regulations in the 1960s specified maximum fuel tank capacity, typically 22 gallons depending on the track and the era. The reasoning was straightforward. Fuel capacity directly affects race strategy. More fuel means fewer pit stops, and fewer pit stops means more time on track at racing speed. By standardizing fuel capacity, NASCAR ensured that every team would have roughly similar fuel windows, forcing everyone to pit at comparable intervals. The rulebook was very specific about the fuel tank itself: maximum dimensions, approved materials, mounting locations, inspection procedures. NASCAR had thought through the fuel tank regulations carefully because fuel capacity was such a crucial competitive factor. But here's the thing about rulebooks: they can only address what the writers think to address. And nobody at NASCAR thought about fuel lines. A fuel line is just a tube that carries gasoline from the tank to the carburetor. On a normal car, it might be 3 or 4 feet long, with an inner diameter of about 3/8 of an inch. It's a simple component that nobody thinks twice about because it's not supposed to be anything special. It just moves fuel from point A to point B. Smokey looked at that humble fuel line and saw something nobody else saw. He saw a second fuel tank hiding in plain sight. The physics are simple. A tube has volume. The larger the diameter and the longer the tube, the more volume it contains. A fuel line with a 2-inch inner diameter running 11 feet through a race car contains approximately 2.6 cubic feet of volume. Convert that to gallons and you get roughly 5 additional gallons of fuel capacity. 5 gallons that NASCAR never weighed, never measured, never even thought to look for. Smokey's fuel line snaked throughout the car, through frame rails, around the roll cage, behind panels, wherever there was space to route it. It looked complex and purposeful, like some sort of cooling system component or hydraulic line. Nobody questioned it, because nobody thought to question it. The fuel tank itself was perfectly legal, exactly 22 gallons passing inspection every single time. The fuel line was just a fuel line, right? The advantage was enormous. In races where fuel mileage determines strategy, 5 extra gallons can mean the difference between making a pit stop and not making one. At superspeedways like Daytona or Talladega, saving one pit stop, which typically takes 15 to 20 seconds, could vault you from mid-pack to the front. At shorter tracks where fuel windows are tighter, those extra gallons provided a cushion that allowed Smokey's drivers to push harder without worrying about running dry. The most famous story about Smokey's fuel line has achieved legendary status in NASCAR lore. According to the tale, NASCAR officials became suspicious after Yunick's car kept posting mysteriously good fuel mileage, staying out longer than other cars between pit stops. They couldn't figure out how he was doing it. Finally, they pulled the car into the inspection area and decided to investigate the fuel system thoroughly. They removed the fuel tank for a close examination. The tank was legal. Exactly 22 gallons, nothing suspicious. At this point, the story goes, Smokey walked over to the car, which was sitting there with no fuel tank installed, started the engine, and told the bewildered officials better make it 10 before driving the car back to his garage in Daytona Beach on nothing but the fuel remaining in that massive fuel line. Now, here's where I have to inject some honesty into the legend. Smokey himself later said this story wasn't entirely accurate. He admitted that the car could technically have run for a short distance without the tank because of the fuel stored in the line, but he didn't actually drive it all the way back to his shop. The car probably moved a few hundred yards at most before running dry. But here's what matters. The story is plausible. The fact that anyone could believe a car drove away without its fuel tank tells you everything about how clever the system was. NASCAR eventually figured out what Smokey was doing. They measured the fuel line, calculated its volume, and realized they'd been had for years. The rulebook was immediately amended to specify not just fuel tank capacity, but also maximum fuel line diameter and length. Modern NASCAR regulations are incredibly detailed about every component of the fuel system, down to the type of fittings, materials, wall thickness, and routing paths. All of that specificity exists because of one clever mechanic who saw opportunity where everyone else saw a simple tube. Smokey tried other fuel-related tricks too. There's a story about a basketball installed inside the fuel tank. The concept was simple. Before inspection, the basketball was inflated, displacing volume inside the tank. The tank would measure at the legal capacity. After passing inspection, the basketball was deflated, creating extra space for fuel. Whether this specific trick actually worked is debated, but NASCAR banned it too just to be safe. When you're dealing with Smokey Yunick, you ban everything you can think of and then add a few more prohibitions just in case. The fuel line saga illustrates something fundamental about Smokey's approach to racing. He didn't break rules. He found the spaces between rules where nothing was written and exploited those empty spaces. The rulebook said fuel tank capacity was limited. It didn't say anything about fuel line capacity, therefore fuel line capacity was unlimited. It was logical. It was legal in the strictest technical sense, and it was absolutely infuriating to everyone trying to enforce fair competition. This brings us to the most legendary Smokey Yunick story of all, one that has been told so many times in so many variations that the truth has become almost impossible to pin down. It involves a Chevrolet Chevelle, the 1966 Daytona 500, and claims so audacious that people still argue about what actually happened more than 50 years later. Trick number 1, the incredible shrinking Chevelle Smokey Yunick 7/8 scale car. The myth goes like this. In 1966, Smokey built a Chevrolet Chevelle for driver Curtis Turner that was secretly constructed at 7/8 scale. Every dimension was reduced by 12.5%. The wheelbase was shorter, the body was narrower, the roofline was lower. It was basically a shrunken replica of a production Chevelle, small enough to be dramatically more aerodynamic but close enough in appearance that nobody noticed. A car built to 7/8 scale would have roughly 30% less frontal area than a full-size version. Less frontal area means less aerodynamic drag. Less drag means higher top speed for the same horsepower. On a superspeedway like Daytona, where cars spend most of the lap at full throttle, this advantage would be enormous, worth multiple miles per hour on the straightaways. The story has been repeated in books, documentaries, magazine articles, and countless barroom conversations. It's become one of the defining legends of NASCAR history, proof of Smokey's audacious genius and willingness to push boundaries further than anyone else dared. Here's the problem. The 7/8 scale story is almost certainly false, and Smokey himself debunked it. In his autobiography and in the 1987 Circle Track magazine article, Smokey explained what actually happened with the Chevelle. A car built to true 7/8 scale would be dramatically smaller than a production vehicle, roughly the size of a Chevrolet Vega. Anyone standing next to it would immediately notice something was wrong. The proportions would be obviously off. The driver would look enormous behind the wheel. Rival teams and NASCAR officials would spot the deception from 50 feet away. What Smokey actually did was far more subtle and, I would argue, far more impressive than simply building a scale model. He made a series of small modifications that individually were almost undetectable, but collectively added up to a significant advantage. First, he moved the entire body backward on the chassis by about 2 inches. This shifted the aerodynamic center of pressure rearward and improved weight distribution, both critical factors for handling on oval tracks where cars are constantly turning left. Moving weight rearward also put more load on the rear tires, improving traction out of corners. Second, he lowered the roof slightly and raised the floor. This reduced the car's overall height and profile without changing the external dimensions enough to be obvious. A lower car has a lower center of gravity, which means better handling in corners. It also presents a slightly smaller frontal area to the wind, reducing drag. Third, and this is where Smokey's genius really shows, he offset the entire chassis to the left. NASCAR rules stated that the engine had to be centered between the frame rails, but the rules didn't specify where the frame rails had to be positioned relative to the body. By shifting the frame and all major components leftward within the body shell, Smokey improved weight distribution for the constant left-hand turns of oval racing. Think about what happens when a car turns left continuously for 500 miles. Centrifugal force pushes everything to the right. The car wants to roll onto his right side tires. By offsetting weight to the left, you counteract that force and keep the car more balanced through corners. This isn't cheating, it's physics, and Smokey understood physics better than almost anyone in the garage. Fourth, he narrowed the front and rear bumpers, smoothed the floor pan, and repositioned components for better airflow underneath the car. Every modification was designed to reduce drag or improve handling, and every modification existed in an area the rulebook didn't specifically address. The combined effect was a car that looked like a Chevelle, passed template inspection because the key measurement points hadn't been altered, but performed dramatically better than any other Chevelle on the track. Curtis Turner took the car to Daytona in 1967 and qualified on the pole for the Daytona 500. The car passed technical inspection, though NASCAR officials knew something was different. They just couldn't figure out what. Then Turner crashed the car at Atlanta later that season. When NASCAR officials finally got to examine the wreckage closely during the rebuild process, they discovered all of Smokey's modifications. The offset chassis, the repositioned body, the narrowed bumpers, the aerodynamic tricks, none of it was explicitly illegal according to the rulebook as written, but also violated what NASCAR believed the rules intended. NASCAR declared the car illegal and banned it from competition. They also implemented new rules requiring cars to fit precise templates, not just at a few key points, but across the entire body. If your car didn't match the template everywhere, you didn't race. Smokey built a second Chevelle for the 1968 Daytona 500, incorporating everything he'd learned. NASCAR rejected it during inspection. That car never turned a competitive lap. By then, NASCAR knew to scrutinize anything with Smokey's name on it, measuring everything multiple times and assuming that whatever they couldn't find was probably the thing he was hiding. The Chevelle saga fundamentally changed how NASCAR approached technical inspection. Before Smokey's creative modifications, templates were simple tools that checked a few key reference points. After Smokey, templates became comprehensive measurement systems that covered virtually every surface of the car. Modern NASCAR inspection uses laser scanners that create three-dimensional digital models of each car, comparing them against master specifications to tolerances measured in thousandths of an inch. That level of scrutiny exists because one mechanic from Daytona Beach kept finding ways to make cars faster without technically breaking any rules. What strikes me about all 5 of these tricks is the common thread running through them. None of these teams saw themselves as cheaters in the traditional sense. They weren't falsifying documents or bribing officials or sabotaging competitors. They were engineers who read the rulebook carefully and found the negative space, the areas where rules didn't exist because nobody had thought to write them. Gary Nelson with his Buckshot saw that weight was only checked before races. The nitrous team saw that tech inspection wasn't thorough enough to find hidden systems. Roger Penske saw that panel thickness wasn't specified. Smokey Yunick saw that fuel lines and body positioning weren't regulated. In each case, the response from sanctioning bodies was the same: close the loophole, tighten the rules, improve inspection procedures. The cat-and-mouse game between racers and officials has been going on since the first organized race, and it continues today. The methods have just gotten more sophisticated on both sides. Let me take you behind the scenes of how modern NASCAR technical inspection works, because understanding the present helps you appreciate just how wild the past really was. Today's inspection process begins before cars even arrive at the track. Teams submit detailed CAD drawings of their vehicles to NASCAR weeks in advance. These digital models are compared against approved specifications, and any deviations must be explained and approved before the car can compete. At the track, cars pass through multiple inspection stations. Laser scanners map the entire body surface, comparing it against the approved digital template. Any deviation larger than a few thousandths of an inch triggers a red flag. Engine components are checked against approved specifications, with seals placed on critical parts to ensure nothing is changed between inspection and race time. Weight is checked multiple times before qualifying, before the race, and after the race. The fuel system receives particular scrutiny. Fuel cells are weighed empty to verify their capacity. Fuel lines are inspected to ensure they meet diameter and length specifications. The entire fuel delivery system is checked for any modifications that might allow additional capacity. Smokey's 11-foot fuel line wouldn't survive 5 minutes under modern inspection protocols. Post-race inspection has become equally rigorous. The top finishing cars are immediately impounded and subjected to comprehensive teardowns. Engines are disassembled and measured against specifications. Fuel samples are tested for illegal additives. Body panels are checks for any changes that might have occurred during the race. If you try to shed weight during a race like the Buckshot trick, you'll fail post-race weight inspection and lose everything you gained. The sophistication of modern enforcement has pushed cheating into increasingly subtle areas. Teams now look for advantages in software, in aerodynamic interpretations, in setup tricks that exist in gray areas of the rulebook. The big, bold cheats of the past, the disappearing weight and hidden horsepower, those simply aren't possible anymore. But the mindset that drove those innovations, the relentless search for competitive advantage, that hasn't changed at all. Consider the 1998 Daytona 500, when Dale Earnhardt finally won NASCAR's biggest race after 20 years of trying. His crew chief that day was Larry McReynolds, but the car was prepared by Richard Childress Racing's technical team, using every legal advantage they could find. After the race, rumors circulated about the car's restrictor plate being slightly larger than allowed, or the intake manifold being modified in some clever way. NASCAR inspected the car thoroughly and found nothing illegal. But the whispers persisted because everyone knew that in NASCAR, there's always something you haven't found yet. Or consider the 2013 Richmond race manipulation scandal, where Michael Waltrip Racing was caught ordering driver Clint Bowyer to spin his car intentionally, triggering a caution that helped teammate Martin Truex Jr. make the playoffs. This wasn't a technical cheat like the ones we discussed. It was strategic manipulation of race outcomes. NASCAR responded with massive fines, point penalties, and suspensions. The incident showed that cheating had evolved beyond mechanical tricks into the realm of competitive manipulation. The most recent major scandal involved the 2022 championship, when Kyle Larson's Hendrick Motorsports car was found to have improperly modified rear suspension components after winning the title. NASCAR confiscated parts, issued fines, and suspended crew members. Even at the highest level of the sport, even with the most sophisticated inspection procedures ever developed, teams are still finding ways to push boundaries. This brings up an interesting philosophical question. Where exactly is the line between innovation and cheating? Every major advancement in racing technology started as someone trying something new that the rules didn't explicitly allow. Ground effects aerodynamics, now a fundamental part of racing car design, were initially viewed with suspicion. Turbocharging was controversial when it first appeared. Even disc brakes and fuel injection faced resistance from traditionalists who thought they violated the spirit of stock car competition. The difference, I think, lies in intent and concealment. When a team develops a new technology and presents it openly to officials for approval, that's innovation. When a team hides a modification designed to deceive inspectors and provide an unfair advantage, that's cheating. The Buckshot was hidden. The nitrous was hidden. The acid dipping was hidden until the panels were measured. Smokey's chassis offset was hidden within the body shell. These weren't innovations submitted for approval, they were deceptions designed to evade detection. But even that distinction gets murky. Smokey would argue that he wasn't hiding anything. The car was right there in the inspection station. NASCAR could have measured the chassis offset or the body positioning at any time. They just didn't think to do so. Is it Smokey's fault that NASCAR's inspection wasn't thorough enough? Or is it NASCAR's responsibility to anticipate every possible modification and write rules to prevent them? The answer, historically, has been that both sides bear responsibility. Teams will always push boundaries because that's the nature of competition. Sanctioning bodies will always tighten rules because that's the nature of enforcement. The game never ends. It just evolves. Let me tell you about a more recent example that shows how this dynamic continues. In Formula One, the 2021 season saw Red Bull and Mercedes battling for the championship in what became one of the most controversial seasons in the sport's history. Throughout the year, both teams accused each other of various technical violations. Red Bull's flexible rear wing became a major talking point, with video evidence appearing to show the wing bending at high speed to reduce drag in ways that seemed to violate regulations. The rules stated that wings must remain rigid and not move under aerodynamic load. But Red Bull's wing passed the static deflection tests that the FIA used to check compliance. Critics argued that the wing was designed to pass the specific tests while still flexing during actual racing conditions. The FIA responded by introducing more rigorous testing procedures, which Red Bull then passed. But the debate continued about whether the wing was legal in spirit, even if it was legal according to the letter of the tests. This is the exact same dynamic we saw with Smokey's fuel line or the Buckshot trick. The rules said one thing, the tests checked certain parameters, and clever engineers found ways to meet the test requirements while still gaining advantages. The rules were designed to prevent. The only difference is that modern teams use computational fluid dynamics and finite element analysis instead of acid baths and lead pellets. IndyCar has faced similar challenges. The series runs spec chassis and engines to reduce costs and equalize competition, but teams still find advantages in setup, in aerodynamic adjustments within allowed parameters, and in preparation techniques. The 2018 season saw Team Penske face penalties for unapproved modifications to their pit equipment. Even with highly standardized cars, the drive to find edges persists. Sports car racing has its own history of creative interpretation. The 1995 24 Hours of Le Mans saw McLaren win overall with their F1 GTR, a car that pushed the boundaries of GT regulations so far that new rules were written specifically to prevent anything similar. The Porsche 962 of the late 1980s used sophisticated telemetry and traction control systems that were technically legal, but so advanced that they triggered rule changes mandating simpler electronics. The pattern repeats across every form of motorsport. Rally teams have been caught with illegal engine maps that activate only under certain conditions. Motorcycle racing has seen controversies over tire construction and electronic rider aids. Even sailing, which you might think would be immune to mechanical cheating, has seen America's Cup teams accused of illegal hull modifications and hidden hydrodynamic features. What unites all of these examples is the fundamental tension between competition and regulation. Racers want to win. Rules exist to ensure fair competition, but defining fair competition is remarkably difficult when technology and creativity constantly outpace the people writing regulations. I think there's something admirable about the cleverness displayed in these stories, even while acknowledging that the behavior was ultimately unethical. Gary Nelson's Buckshot system was genuinely brilliant engineering. It exploited a procedural gap that nobody had considered, implemented a solution that was virtually undetectable, and provided meaningful competitive advantage. The fact that it was cheating doesn't diminish the creativity involved. Similarly, Smokey Yunick's fuel line was a masterpiece of lateral thinking. Everyone else saw a tube that moved gasoline from tank to engine. Smokey saw a potential fuel reservoir that the rules hadn't addressed. That kind of creative vision is rare, and it's the same kind of thinking that produces legitimate innovations in every field. The difference between a celebrated innovator and a notorious cheater often comes down to timing and context. If Smokey had submitted his chassis offset modifications to NASCAR for approval and they'd been accepted, he'd be remembered as a pioneering engineer who improved oval track handling. Because he hid the modifications and tried to deceive inspectors, he's remembered as a cheater. The innovation itself was neutral. The concealment made it unethical. Modern racing tries to channel that creative energy in legitimate directions. Series like Formula One have developed collaborative technical working groups where teams propose innovations and officials evaluate them before implementation. NASCAR has technical bulletins that clarify rules and allow teams to request pre-approval for modifications. These processes don't eliminate the cat-and-mouse game, but they do provide legitimate pathways for innovation that don't require deception. The legends persist, though. When someone mentions Smokey Yunick in a racing conversation, nobody talks about his legitimate victories or his respected career as an engine builder. They talk about the fuel line, the Chevelle, the basketball in the fuel tank. The cheats define the legacy more than the legitimate accomplishments. Perhaps that's because the cheats reveal something fundamental about the competitive spirit. Everyone who straps into a race car believes they're good enough to win if only they had a fair chance. The cheaters went further. They believe they deserve to win so much that they were willing to bend reality itself to make it happen. That kind of belief, even when it crosses ethical lines, resonates with anyone who has ever competed for anything. Looking back at these 5 tricks, I'm struck by how they represent different eras of racing and different approaches to finding advantages. The Buckshot trick was mechanical and procedural, exploiting a gap in when inspections occurred. The nitrous scandal was chemical, hiding power enhancement where nobody thought to look. The acid dipping was material science, altering the fundamental properties of the car's construction. The fuel line was geometric, using volume and space in unexpected ways. The Chevelle modifications were positional, shifting components within allowed tolerances to create cumulative benefits. Each approach required different expertise and different kinds of thinking. Gary Nelson needed to understand NASCAR's inspection procedures intimately, knowing exactly when weight was checked and when it wasn't. The nitrous teams needed to understand both the chemistry of combustion enhancement and the art of concealment. Roger Penske's team needed contacts at Lockheed Aerospace and the willingness to try an industrial process never before applied to racing. Smokey needed to visualize space differently than everyone else, seeing the car not as a collection of components, but as a system of volumes and positions that could be optimized. What happens when you combine all of these approaches? You get modern motorsport engineering, where teams employ hundreds of specialists covering every discipline from computational fluid dynamics to material science to data analytics. The cheats of the past weren't just rule violations, they were proof of concept experiments demonstrating that advantages existed in unexpected places. Today's teams search for those same advantages, just through legal channels with massive budgets and sophisticated tools. The relationship between past cheating and present engineering is direct and traceable. NASCAR's current inspection procedures exist because of specific incidents we've discussed. The template system came from the Chevelle. The fuel line regulations came from Smokey's invisible tank. The post-race weight checks came from the Buckshot. Every rule in the modern rulebook has a story behind it, usually involving someone who found a way around the previous version. This evolutionary process has made modern race cars extraordinarily refined. A current NASCAR Cup Series car is specified down to incredible detail. Body panels must match digital templates to thousandths of an inch. Engine components must fall within exact tolerances with seals verifying nothing has changed between inspection and competition. Weight must be met before qualifying, before the race, and after the race. Fuel capacity is verified through multiple methods. The gaps that Smokey and Gary Nelson exploited simply don't exist anymore, but new gaps appear as technology changes. The introduction of electronic fuel injection created questions about engine mapping that didn't exist with carburetors. Hybrid power systems in Formula One and sports car racing have created new gray areas around energy recovery and deployment. Data systems that monitor everything from tire pressure to brake temperature create opportunities for software advantages that would have been science fiction in the Buckshot era. The most successful teams today find legal advantages in the margins. They optimize within allowed parameters rather than outside them. They use simulation tools to test thousands of setup combinations before arriving at the track. They employ strategists who game out every possible race scenario to make optimal decisions in real time. The creativity that once went into hiding Buckshot now goes into computational modeling and data analysis. Yet something has been lost in this evolution toward total regulation. The stories from the Buckshot era have a romantic quality that modern technical infractions lack. When a current team gets penalized for a rear suspension component being 2 millimeters out of specification, it doesn't capture the imagination the way Smokey driving away without a fuel tank does. The cheats were more audacious when enforcement was more relaxed, and audacity makes for better stories. Maybe that's why we keep telling these tales. They represent a wilder time in motorsport when individual cleverness could overcome institutional resources, when a mechanic with a good idea could outthink an entire sanctioning body. Today's advantages require millions of dollars in wind tunnel time and hundreds of engineers working in coordination. Smokey built his 11-foot fuel line in his shop in Daytona Beach with hand tools and sheer determination. The lessons from these stories extend beyond racing. In any competitive field, rules exist to create fair competition. But creative people will always look for edges within or around those rules. Tax codes have loopholes because legislators can't anticipate every strategy accountants will devise. Sports have equipment regulations because athletes and manufacturers will optimize anything not explicitly prohibited. Business has antitrust law because companies will pursue advantage through any available means. The response is always the same: close the loophole, tighten the rules, improve enforcement, and then wait for the next creative mind to find the next gap. The cycle never ends because competition itself never ends. As long as someone wants to win more than they want to follow the spirit of regulations, there will be people finding buckshot tricks and invisible fuel tanks in whatever field they compete. For racing specifically, these stories serve as reminders of where the sport came from and how it evolved. Every current rule has a reason. Every inspection procedure addresses a historical vulnerability. The rulebook is a living document written in response to human creativity and competitive drive. So there you have it. 5 racing tricks so clever, so perfectly executed, that they forced permanent rule changes and became legends in motorsport history. Disappearing weight that scattered across Bristol Motor Speedway. Hidden nitrous systems that stole pole positions at Daytona. Acid, dipped bodies that you could dent with your finger. Fuel lines that held more fuel than the actual tank. Chassis modifications so subtle that cars passed inspection while being fundamentally different from production vehicles. These weren't just cheaters trying to get ahead. These were engineers and mechanics who saw possibilities that nobody else imagined, who looked at rulebooks and found the empty spaces where advantages lived. Their methods were unethical, their deceptions were eventually discovered, and their tricks were ultimately banned. But their creativity changed racing forever, forcing the sport to evolve and mature into what it is today. Which trick did you think was the most ingenious? Drop your answer in the comments below. If you enjoyed this deep dive into racing's most legendary rule benders, hit that subscribe button and notification bell so you don't miss future videos exploring the technical innovations and creative engineering that have shaped motorsport history. Thanks for watching, and I'll see you in the next one.